are from the C23 PC607 team Capstone project consisting of 6 members would like to present the Capstone project that our team has worked on. The namely is rice crop quality analysis. And before we start the presentation of our Capstone project, let me introduce our members in this team. The first me, Putri Nagita Cahyani, and Harun Al-Jafar, Marwika Rifatul Ifa, Amri Mufti, Sally Valencia, and Harun Al-Jafar. And the next table of contents will be explained. The first one is about background, and the second is about recent. The third is existing result, implementation. 5 is result. 6 documentation, deployment plan, and the last is business pitch. Next.
Okay, so I'm Aljafanis. I will say I will show you this background why we make this application. So the background is this study specifically addresses the challenge faced by rice farmer and agricultural professionals in Indonesia regarding the quality and productivity of their rice crops, particularly in light of climate change and food security concerns. Through an extensive literature review, it has been identified that the potential occurrence of El Nino in 2023 and 2024 poses a significant threat to rice production due to the increased risk of drought and pest infestation. The literature review has also revealed a gap in the availability of efficient solutions to assist farmers in accurately assessing the quality of their rice crops. Therefore, the primary objective of this research is to develop a solution called QRISE, which leverage machine learning techniques to analyze image the quality of rice crops, addressing this innovative solution and to detect and determine the quality of rice crops, addressing the identified gap and offering a promising approach to tackle the challenges faced by the agricultural industry in Indonesia. Ultimately, the research endeavors to enhance rice productivity and yield, ensuring sustainable food production in the face of evolving environmental conditions. Next, the reasons why we make this is because rice is a vital crop in Indonesia, and addressing the challenge faced by rice farmers aligns with the country's agricultural priorities for now. The climate change impacts the rice everywhere. The potential occurrence of El Nino poses threats such as drought and pest infestation, which can significantly affect rice production in Indonesia. And the last thing, lack of accurate assessment methods. The existing methods to assess the quality of rice crops may be inadequate or time-consuming. The existing results of this app is we will reduce the time-consuming and subjective and the large quantities. Next.
So for the machine learning part, we use the datasets on kaggle.com. We use 4 datasets for image recognition about one rice leaf disease dataset. This dataset is used to identify disease commonly experienced by rice, such as leaf smooth, brown spot, and also blast. Second is rice variety dataset. This dataset is used to distinguish the types of rice, including arborio, basmati, ipsala, jasmine, and karacadak. 3 is seed quality of rice dataset. We use this dataset to identify which rice seeds are superior or not, so that it can produce quality of rice. And last is nutrient deficiency leaf dataset. This dataset is useful for information on the presence of nutrient deficiencies in each rice seen from the image of the rice leaves. The nutrient deficiencies that can be identified through this dataset are nutrients that are essential for rice, such as nitrogen, potassium, and phosphorus. Next. The libraries we use include TensorFlow as a machine learning algorithm, Matplotlib as a library used for data visualization, NumPy for data processing, and Pandas for data preprocessing.
In this slide, we saw one of the data processing coding for our machine learning model. The algorithm used can be seen in the slide is DenseNet 201. We use the DenseNet 201 algorithm after considering using other algorithms such as GNN, TransNet, or VGG16. In the next slide, it can be seen that after the algorithm is applied and tested, the accuracy we get is 0.96 or 97% 6% in just 5 efforts. When comparison the accuracy result with other algorithms, we think this accuracy is high enough to be able to prove that DenseNet 201 can be used as the most suitable algorithm and can be used as the image identification we do. It also illustrates how fast the algorithm can recognize the desired things such as the characteristic of rice that lack nutrition, superior seeds, the appropriate type of rice, or disease suffered by rice. Next.
So our cloud computing architecture for QRISE begins with a client who sends a request to the QRISE server. The clients initiate the process by sending requests to the QRISE server, which serves as the entry point for the cloud-based systems. The QRISE server calls the ML server to predict the desired outcome. On receiving the client's request, the QRISE server communicates with the ML server to perform the necessary computations and predict the desired outcomes. As part of the workflow, the QRISE server uploads the relevant image to Google Cloud Storage, where it will store truly for further processing. To perform accurate predictions, the ML server retrieves the appropriate machine learning model and the corresponding image file name from the QRISE server. After performing the necessary computations, the ML server sends the response back to the QRISE server. The QRISE server receives the response from the ML server and returns to the clients, providing the predicted outcome or relevant information. And the Cloud SQL used to store transactional data. To streamline the development process, we leverage Cloud Build to automate tasks such as building, testing, and deploying applications. And the next slide. Here are the tools we use for the cloud computing. We leverage JWT authentications for the authentications, and we use different two frameworks, Node.js and Express for the QRISE server, and Flask for the machine learning server. And we deploy the server into Google Cloud Services and document all the REST API using Swagger. The Swagger can be seen in the right side of the slide. We can interactively send requests and get a response. And on the left side of the page, we can see requests sent by the client.
Now you are looking at our four main interfaces. In the homepage, you can choose one of our four surveys. You will then be redirected to the image uploading page, where you can upload a photo of your plant or take a picture with a camera feature. The image will then be processed with machine learning, and after clicking the upload button, you can see the result. You can view your history in the history page. Our app is developed with a Kotlin programming language. The retrofit, retrieve, and upload data via REST API. You can check our documentation in this link. Now I'm going to explain about the local deployment. In the first month, which is month of July, we will conduct a pilot program with selected rice farmers and agriculture professionals for testing and feedback. Then in the second month, we will develop marketing materials, including brochures, presentations, and a website. Then in the next month, we will build strategic partnerships with agriculture organizations and government agencies. In the last month, we will launch QRISE and in the local market and implement distribution channels. Now I'm going to cover a special topic in this slide, which is financing. What if QRISE gets a funding injection of 5K USD or 10K USD? Okay, for the 5K, how will it be divided? First, 10% of the share will be used for cloud services, both on API usage as well as deploying the application. Next, for the next 20%, we use for hardware, software, and paid licenses. With capable hardware and software, we can fix some errors or bugs and cut down the time spent on testing data. For the payment of all employee salaries, we charge 30% of the total funds. Lastly, and most importantly, marketing that targets the right target. Business analysis to reach regional farmers is also needed. Therefore, we give a figure of 40% of the existing funds so that marketing can make this QRISE application attractive to both traditional farmers and modern farmers. Next.
Okay, I think that's all presentation from our team. We apologize if we have any mistake, and thank you.